Right, if you've got three numbers, oh, I don't know what they are. Right, if you've got to add those three together, you can. You don't have to add all three at once. Because if you add all three at once, you've got to work out really complicated carries. Alright, so if you did that would be what answer? If you added those three in that column together. Now, don't worry about what the column heading means. Yeah, so that's in binary 1, carry 1. But you can get instances where you get 4. Because if we'd have had a carry 1, that would be 4. So you'd say that's 0, carry a 0 and a 1. So it's horrible. So you can do them in pairs. So my advice, to keep it simple, unless you're happy doing that, is do it in pairs. So with this one, what I'd do is I'd say, right, okay, don't worry about the one at the top to start with. So I'm going to add these two together. So just go 1 and 0 is 1. 1 and 1 is 0, carry 1. 0, carry 1. 0, 0 and 1 is 1 and 1. Right, so that's part of my answer. Take my other one, so I'm going to rewrite it down here so I've got it. And add it. Then just go 1 and 0 is 1. 1 and 0 is 1. 1 and 1 is 0, carry 1. 0, carry 1. Now, that goes into the carry bit. Now, if they're just saying add it up, okay, what would that mean if these were signed numbers? If you had a 1 at the front? It'd be a negative. So, it might be that that's required for the answer. But if they say, in a fixed number of bits, ignore the carry. Okay. Not that I said that.
You can actually get smaller.
Well, yeah, but that wouldn't. Yeah, because we can get smaller if you add a 5 and minus 7.
I was not saying add numbers together. Don't worry about the hundreds.
Yeah.
Sort of
It would
so
be, yeah.
like
But that's because we have to worry when we're computing about how much space we've got.
That's like 50 and 60, but it's going right in the hundreds column, so you write down 10.
Yeah, think about it. If we've got an 8-bit, all we can do is 8-bit storage, and we try to add 50 and I don't know 80. What's the answer to that? 50 plus 80. What? 130. With an 8-bit value, whether I use sign of magnitude or 2's complement, what's the biggest positive number I've got?
2 plus 5.
No, that's unsigned.
Oh, 127.
127. So that wouldn't fit. What do we call that when we get a result from a calculation that's bigger than what we can store? Begins with O. Overflow. Like when your bath has got too much water in it, what does it do? It overflows. Overflow. And really, we have to decide what we do when we get overflow. Okay? But we get it a lot. You get it even more when you're doing multiplication. In fact, it happens so much with multiplication that CPUs generally use double-sized radiuses when they're doing multiplies. So they don't keep getting overflow issues to deal with. So you have to worry about that. Okay, so you might get two positive numbers that they want you to add up and say, what's happened here? If it's too big, and you have to say, well, actually, overflow's occurred. We can't hold that number. Don't forget, the nice thing about this, we can work out what these numbers are and work out what the answer should be. Can't we? That's the great thing. By converting them to decimal and doing it in decimal. So don't ever forget to do that. You can always double check your answers for this. So if you get a weird result and you say, I don't understand that, it should have been -2. Okay? Check yourself. I'll go through all this again when we come back, because there will be a question on it. They'll either give you an addition or a subtraction to do, won't they? But don't forget that overflow, and the thing at the end goes into the carry bit, and then we decide whether we use that carry value or not. But yeah, I would not advise unless you're really happy with it, Mohammed, adding 3 numbers at once. Because if we just do this one, so that was the answer we got. So let's remember that. We got that as our final answer. So let's see if I can do it without cocking it up. Will be the starting point. So I'm going to add all that up, and it obviously should give me the same answer. Shouldn't it? Yeah? It should give me that. So we got 0, 1 and 0 is 1. Really good. Right, this is our 1 carry 1. So we've got 1 carry 1. We've got 0, 1, 0 and 1, which is 0 carry 1. That is 1, 0, 0 and 1, which is 0 carry 1. 0, 1, 0 and 1, which is 0 carry 1. Yeah, so it did work, but you can easily make a mistake on the carry. If you get a 4 to carry, because you can if you've got 3 values, you've got to remember, so if you've got that to add up and you've got a carry from the previous one, because you added up a 1, a 0 and a 1, you've got to go, oh, that's 4, so that's 0, carry a 0 and a 1, because 1, 0, 0 is 4 in binary. So, it's no harder. It's no harder, but there are more opportunities to make mistakes. And in the exam, we're trying to reduce the number of mistakes. If we can do a question, we want to make sure we get the marks. We don't want to lose the marks because we made a daft mistake. Daft mistakes kill lives, don't they? Always double check the answer. Right, just as a matter of interest, what are these numbers? So what's that number? It's decimal. Let me just do some. Yeah, that looks like 10. So that was 10. What's that one? Right, assume they're just. Well, let's assume that that's 2's complement. It's 2's complement. What is it? So I'll flip all the bits and add 1. So 0, 1, 0, 0, 0. Add 1, so that comes a 1. That's minus 9. So we're adding minus 9. This number was just 2. So the answer was 3. Now remember, that was the carry, so I said ignore that. What's the answer? 3. So it did work. But you can double check yourself. You don't do arithmetic with sign of magnitude. It will always be 2's complement. Okay? Because if it is, you've got to start taking the sign bit off. And if you're adding a negative number, you've got to subtract it. And remember, I haven't even shown you how to do subtraction, because you don't need to, because we can use 2's complement to add the negative value of, or to times by minus 1 the value. So that was, the answer was 3, which is what that is. So the actual thing that rolled into the carry didn't matter for this example. Okay, that's it.